Okay, this is exercise 5.10, integration of trig functions. Now we know that integration is the reverse process of differentiation. Do you remember that when we differentiated sine, we got cos, and it was positive, you see. So when we differentiate sine, we get cos. So therefore, when we integrate cos, we get sine. No, but it stays positive. I'll show you why. Yep. No. Back, before we write the rule. Last lesson we did if y equals sine x, then dy dx is cos x. So the opposite, that's differentiating. The opposite is to integrate. Therefore, the integral of cos of x dx is sine x plus c, and it's positive. So that's your integration rule. Because when you differentiate sine, you get positive cos, it means that when you integrate cos, you get positive sine because it's the exact opposite, okay? So that's the first rule. The second thing that we did last week was to differentiate cos x, and when we differentiate cos, we get negative sine. So therefore, now we don't integrate negative sine, we integrate sine x, but when you integrate sine, you get a sign change. So you get negative cos x plus c. So, because when you differentiate cos to get sine, you have a sign change. So therefore, when you integrate sine, you'll get cos, but the sign will be the opposite. So if you integrate sine x, you get negative cos x. All right, we don't integrate negative sine x. We integrate sine x to get negative cos x plus c. Got that? So we're just looking at our differentiation rule, just looking back at what happened with differentiation to compare the integration rule, okay? The other differentiation rule we learnt was if y equals tan x, then dy dx is sec squared x. So therefore, we don't do the integral. There's no integral of tan at the moment. We do that. That's a harder example. We do integral of tan when we're doing log functions. When we integrate logs, we do the tan function. Can't do it here. The only thing is the reverse process of this. So we can integrate what? Sec squared x. So the integral of sec squared x is tan of x plus c. Now they're the straightforward, so that's the differentiation, and these are the integrations in the boxes, okay? Of a function rule. Now I'll bring up the formula sheet in a minute so that we can have a look at it so that you know what's on it. If you integrate something of the type cos, I'll do cos because it's the positive one first, cos of ax plus b dx. So you're integrating cos of ax plus b dx. In other words, that means it's not cos function of x. That's not what it says. It has to be of the format something x plus a constant. Now the constant can be 0, no problem. But this is like integrating cos of 2x, cos of 3x, cos of negative 5x, etc. No x squareds, no x cubes, no other functions. Ax plus b means that type. So if you integrate that, you get 1 on a sine ax plus b plus c. One sec. The proof. So you need to box that one up. Okay. Proof. If y equals sine of ax plus b, this is the type we did last week. So if y equals, say, sine 2x plus b or whatever, how do we differentiate that? Don't we get cos ax plus b, then what do we do? Times the derivative of that, which will be a. So we get a cos ax plus b. So, yes, that's right. Thank you. Dy dx, yes. Big problem. So if y equals sine ax plus b, then dy dx is cos ax plus b times a, which is a cos ax plus b. So therefore, the integral of a cos ax plus b with respect to x. So if you differentiate that, you get that. If you integrate that, you get. So if you integrate it with an a, what do you get? You get the top. But isn't that the same as a times the integral of cos? No, I won't do that. So you get the top. Whoopsie. So if you integrate that, you get the top, don't you? All right, so actually I will put it there, one sec. So if you integrate that, you get sine of ax plus b plus c. But that's not what I'm trying to integrate. So isn't my left-hand side really equal to a? Can I take that a out? If I integrate a cos ax plus b with respect to x, it's the same as doing a times the integral, because the constant does not change anything. All right? So that equals that is the same as this equals that. Okay? So they're the same thing. Integral of 2x, for example, is the same as 2 times the integral of x. It's the same. All right? So now I can divide through by a. So therefore, the integral of cos ax plus b with respect to x, if I'm dividing through by a, will be that over a, or 1 on a times sine ax plus b plus c. See, girls, constants at the front don't affect integrations. All right?
What does that mean? You have to divide this by a?
No, don't worry about that. No. I can call this k and then call that. Don't worry about that. Don't worry about the constant. It's fine. So that's the proof of one of those. All right? All right. Normal sine, you get negative. What is wrong with me? Thank you. So integral of sine ax plus b dx is what? Negative cos. Wait, I'm just going to leave a space here. What's it going to be? It's going to be negative 1 on a, similarly. Negative 1 on a cos ax plus b plus c. Okay, so that's the rule for integrating sine of a function, but the function has to be a linear function. Sine of ax plus b. Okay? It's negative 1 on a. Same with integrating sec squared ax plus b with respect to x. Same thing. But when you integrate sec squared, you just get positive tan. So we just get 1 on a tan of ax plus b plus c. Okay? I'm not going to do the proofs for those. Okay. This one, integrate the following. Sine of x degrees over 4. Integrate that with respect to x. That will be the same as integrating sine. X degrees times pi over 180 degrees over 4 dx. Now, the degrees will disappear, so you've got pi x on 180. So the degree symbols actually disappear. So it's the same as integrating sine pi x on 180 over 4 dx. Now, when you integrate sine, you know that when you differentiate sine, you get cos, and there's no sign change. So if you're integrating sine, you're going to get positive or negative cos? Yeah, you get the negative. So you'll get negative cos. You know what? Let's take this quarter out. Can we just keep this quarter out? That is a 1 over 4. It's the same as integrating a quarter sine pi x on 180. You okay with that? So I pull that quarter out so that you don't get mixed up. A quarter times. All right, integrating that, what do you get? Negative 1 on the coefficient of the x. Now the coefficient of the x is pi on 180. So that's negative 1 on a cos ax plus b. You okay with that? So the quarter I would pull out, the 4 from the bottom, the quarter. Sine of pi x on 180. The a is pi on 180, so it's negative 1 on a. So what does that become? a quarter times negative what? Negative 180 on pi. Cos pi x on 180. Which is, are we okay? Sorry, I chose the worst one. Negative 45, because 180 divided by 2 is 90. What? Because 45 on pi, cos of pi x on 180 plus c. All right, sorry, that was a bit of a yucky one. We might do question 1. Okay. Oh, no, that's another sign. Oh, no, question 1F. Yep. Yep. Oh, do they just put it x degrees? They've just put it back to x degrees? So in the answers, they've got negative 45 on pi, cos of x degrees plus c. So they've written it as the question is written. So they've converted it back. Because the question was written with a degree, they've written the answer back with a degree. But that and this are the same. But you should write your answer in terms of how the question's written. But this minus 45 on pi, you can leave that. Okay? So cos of pi x on 180, because sine of pi x on 180 is the same as x degrees. See, but, yeah, but once I put, if I write x degrees, pi over 180 degrees, it's like the degrees symbols cancel. Okay? And pi x on 180 is different to just having x degrees. That is now in radians. So it's 3.14 times whatever x is over 180. All right? All right, the next one. Integrate what? Integrate sine. What happens to the sine? It what? Changes or stays the same? It changes, so you're going to end up with positive cos, aren't you? You don't have to go minus. You can go minus negative 1 on what? 7 cos 7x plus c. But you can just write it as when you integrate sine, the sign changes. You don't have to go take away negative. You can just make it a positive. So it can, oh, why am I doing that? So it's just 1/7. I don't know why I put the integral sign. I'm a bit flippy. There. Sorry, guys. Not quite myself. So, look, I wouldn't put the negative 1/7, the negative 1/7. When you integrate sine, the sign changes. When you differentiate sine, it doesn't change. When you integrate it, it changes. So just go straight from there to that step there, to the answer. And it's like integrating 3 times sec squared x on 3 dx. So it's 3 times, yes. No, it's 1 on that 3. It's 1 on a. What is a? It's the coefficient of the x. Yeah, 1 on a third. 1 divided by a third, tan of x plus c. So what's this become? 3 times 1 divided by a third. The coefficient of the x is a third. It's 1. It's 3 times 3. Yes? I'm good today. Doing a great job today. Oh. Oh, geez. Oh, jeez. Thank you. Not good. Okay. Oh, forget this. So this is sec squared 1/3 x. Are we okay with that? Dx. So it's 3 times 1 on a, 1 divided by a third, tan of x on 3 plus c. So it's 9 tan x on 3 plus c. Okay, we'll do some examples from question 2. We're going to integrate question 2e. I might do a cos one in a minute. I will in a minute. Integral from 1/2 to 0 of sine pi x dx. And then I'm going to do question 2, G. Integral from pi on 12 to 0 of 3 cos 2x dx. Are we ready? So, this is a definite integral, so substitution and no plus c's. What do you get if you integrate sine? It's negative 1 on the coefficient of the x, which is pi, cos pi x. Substituting in the values half and 0. You can pull out the half to the front. I would. I'd pull out the negative 1 on pi to the front. It's not going to be involved in the substitution. Why deal with it twice? Why end up with 3 negatives? I'd pull out the negative 1 on pi to the front, and you do your substitution just on your cos pi x. No plus c, because if you have a plus c, it cancels when you do the minus. So we get negative 1 on pi times cos of what? Substituting in a half. Cos pi on 2 minus cos of 0. No, not minus 0. I've pulled out the negative 1 on pi to the front. So it's negative 1 on pi. What's cos of 90? That's cos of 90, girls. 0. Cos of 0. Here's your cos curve. All you do is you sketch that. That's the cos curve. That's 2 pi. That's pi. So cos of 90 is 0. Cos, right? So you're just multiplying this by negative 1, and you get 1 on pi. Otherwise, if you don't pull that out, you've got negative 1 on pi times that minus negative 1 on pi times cos 0. Why are you going to put 3 negatives in there for? You're just going to make, and all you need is a mistake of a negative to a positive or vice versa. There goes your mark. There goes the question. 1% less. There goes your band 6. All right? So, please don't be substituting. Take the coefficient out, particularly if it's a negative. And then do your substitution on the other bits. The next one. What do we got? Well, isn't it 3 times the integral of that? I'd be pulling the 3 out, by the way. Integrate cos, what do you get? Differentiate sine, you get cos. Integrate cos, you get a normal sine. See, look, if you remember, if you differentiate sine, you get the normal cos. So if you integrate the sign changes. This is 2 unit. So it's just 1 on 2 sine 2x. Notice I've taken the 3 out in the front already, because it's really 3 times that integral between pi on 12 and 0. Why not take the half out as well? Why deal with this half? So put it as 3 on 2 out the front. Sine of 2x, substitute pi on 12 and 0. You're really making your life a lot easier. Why substitute a half twice? So we've got 3 on 2, sine of what? 2 times pi on 12 is what? Pi on 6 minus sine of 0. Sine of pi on 6 is sine 30, which is a half, minus sine of 0 is, so it's just 3 on 2 times a half is 3 on 4. Girls, it is better than dealing with a half out the front there and a half there. Well, I think it is. I'd be pulling all those constants to the front before you do that substitution. All right, girls, in this question we want the shaded area. Now, it's always top curve minus bottom curve. There's the sine curve. There's the cos curve. We have a point of intersection. The shaded area is between the values of pi on 2 and something else. So, girls, no, it's not 0. Yes, sine of, we need to know where does sine x equal cos x. The point of intersection is the simultaneous the solution of the simultaneous equation y equals sine x with y equals cos x, which is sine x equals cos x. How do we solve sine x equals cos x? Or you should know, sine of what equals cos of what? From 0 to 90 degrees. No, so, it's not 30 or 60. What's sine 45? 1 on root 2. What's cos of 45? All right, the point of intersection is pi and 4, but, oh, they actually, yes, they did say, but they may not say in an exam. They did give it to you, but we're going to do it anyway. So girls, this is what we're doing. We're going to work out how you get pi and 4 because I doubt it whether they'll give you the point of intersection in an exam. So if you were asked to find the point of intersection, it is going to be something fairly easy if it's sine x equals cos x. Does occur when it's 45. But do you remember how we solve this? What do you do? What do you divide both sides by? Divide through by cos x, and you get sine on cos is what? Sine x on cos x equals cos x on cos x. So I'm dividing through by cos x, and I get tan x is, what's cos x on cos x? Yep. So tan of what is 1? 45. But in our case, it's pi and 4. Sorry? It's the point of intersection. See, we need the point of intersection of the sine curve and the cos curve. So you would solve simultaneously y equals sine x with y equals cos x, which gives us sine x equals cos x. You divide both. So whenever you're solving sine equals cos, you always divide by cos, because sine on cos is tan. And you end up with only one function. Sine and cos together are tan. Sine divided by cos is tan. So you divide both sides by cos, and you get tan x is 1, so x is 45, or pi and 4. I know they gave you the value on the graph, but it's time we revise that anyway. So the area will be, the x values are pi on 2 and pi on 4, sine of x minus cos x dx. Because that's how you solve the equation sine x equals cos x. We did it last year, but you've forgotten. And off though. Guys, be careful. Differentiate sine. The first thing we did when we integrated and differentiated, we did sine x is cos x. That was the nice one. It was the positive one. Nothing else is nice. So, integrate sine, you get? It's negative cos x. But integrate cos. So if when you integrate sine, you get negative, when you integrate cos, it mustn't change. Only one of them is going to change. You know when you differentiate sine, it doesn't change, the sign? So when you differentiate cos, it does. When you integrate sine, it does change. It's like differentiation and integration are the opposite. So when you integrate sine, the sign changes, so when you integrate cos, it doesn't. One of them will stay the same, the other one will change. So what do I get when I integrate? So I get negative cos x minus, what do I get when I integrate? It just stays the same. It stays as a minus. Between pi on 2 and pi on 4. So we get, negative, negative. And then you've got to substitute with negatives. Pull the negative out. Unless you want to be doing negative, 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 negative. There'll be 5 of them. See how they're both negatives? Isn't that negative? Cos x plus sine x. Pi on 2, pi on 4? Yes or no? So keep it out the front and you'll have a much better time substituting. Negative, but it's got to be around everything. So what do you got? Cos pi on 2 plus sine pi on 2 minus brackets, but I could just subtract both of them. Can we subtract both of them? Minus cos pi on 4 minus. Can I do that? Because it's minus brackets. Or do you want brackets? It's that. All right, I'll do brackets. Plus sine pi on 4. So I've got a negative out the front. Keep that. Right, cos. Now just have your little sketch of cos and sine on the side. Makes it a lot easier. There's cos, there's sine. What's cos pi on 2? 0. Sine pi on 2 is? Because that's pi. 1 minus cos pi and 4, we know what that is. 1 on root 2. Sine pi and 4, 1 on root 2. Remember, there's a negative out the front. Girls, if you look at the question, that area was above. Area between two curves is always going to be positive answer. What you've got in here has to be negative. Otherwise, we're in trouble. So what have I got? 1 minus, what's 1 on root 2 plus 1 on root 2? 2 on root 2. Which is negative 1 plus 2 over root 2. That's the exact answer. Negative 1 plus 2 on root 2. Look, 2 on root 2 is 2 divided by 1.7 approximately. No, 0.07. 0.707. Anyway, have a look. Is it positive? Oh, you want to rationalise it? Negative 1 plus. Remember, isn't 2 root 2 squared? What is it then? In other words, it's root 2 take away 1. It's negative. Oh, I forgot. What's 1.7? What's root 2? Oh, good. Oh, geez. Sorry, everyone. Don't know what made me think it was 0.7. Which one's 0.7 then? 1 on root 2 is 0.7. Root 2 is 1.4. What do you mean? Because 2 is root 2 squared. Look, 2 on root 2. Yes, you can multiply by root 2 on root 2. Isn't that root 2 squared on root 2? Isn't that root 2 times root 2 on root 2? Think, all right, just multiply by root 2 on root 2, and what do you get? On 2, which is, so it's much easier to think of 2 as root 2 squared. Good luck. Okay, top one's much quicker. Between two curves, right, you write units squared, because you're not given whether it's centimetres or whatever. Now for the next question, 6C, find this shaded area. 6A. The first one was 6A from your Cambridge booklet. The next one is 6C. Find the shaded area between the line y equals x and y equals sine x. You're going to have to work out where they cut. And this one you can't solve. You know, when you do, girls, you know the line y equals x, right? It's like when x is a half, y is a half, when x is 1, y is 1, whatever. As long as sine of whatever you're doing, you know the sine curve I think is always below the line y equals x. Because if you try something like sine of, look, pi on 2 means 3.14 on 2. So pi on 2 here is 1.57. So do sine of 1 in radians. See, the 0.11 is somewhere here. So girls, because this is in radians, sine of pi on 2 means the sine of 3.14 divided by 2. It's approximately the sine of 1.57. Now, if you do sine of 1 in radians, as long as you're getting a value less than 1, then the sine curve is always below the line y equals x. Can you do that for me on your calculator? Sine of 1 in radians. You know, for small sine, but in radians, not in degrees, in radians. Sine of 1. 0.8, yeah. So sine of 1 is 0.8. If you do sine of a half, as long as it's in radians, as long as it's less than a half. They do intercept at 0. They do. But I want you to realise that this curve is underneath the line y equals x at all times. So in radians, if you did, and you need to know that this pi on 2 is approximately 1.57, and that this is sine of 1. and sine of a half would be 0.4 something. So the sine curve is always below the line y equals x, so the points of intersection are what? Pi on 2 and, no pi on 2. Where do these two curves come? At 0. Yeah, because the sine curve's always below the line y equals x. So the area will be integral, top curve minus bottom one. What's the top curve? But you don't write y equals x, you just write x minus bottom curve sine x dx. Values are pi on 2 and 0. So you get integral, integrate x. What do you get? Thank you. Because I was going to put 1. X squared on 2, very good. Integrate sine, put the minus, and then we're integrating sine. Well, differentiate sine, you get cos. This must be the negative, so it becomes a plus. Because it's minus minus cos. So it's a plus between the values of pi on 2 and 0. And now let's substitute. Pi on 2 squared is what? Pi on 2 squared is pi on 4. Divide that by 2 and you get pi on 8. You do. You get pi on 4 and then you keep that 2 down there. Pi squared. Thank you. Pi squared on 4 times the 2's at the bottom. Because you get pi squared on 4, you end up with pi squared on 8. Plus cos of pi on 2, what's that? Cos of 90. 0. Minus 0 plus cos of 0. Cos of 0 is 1. So we get pi squared on 8
Could the following ladies please come to the school
minus
office?
1.
Francesca Ryan and
Because
Caroline
that's
Monet.
0 plus cos of 0 is 1. So the exact area is pi squared on 8 minus 1. Unit squared. Oh, jeez.
Attention ladies.